Yes, sir, you can start your live now.
Hello, welcome to the live session of computational quantum chemistry. So here we are going to give answers to your questions, whatever you have. Um, so I'll start with the questions which are given in the form. So Maya Bhatt asked that in Chemira-X, how to optimize the energy of two different molecules together. I gave a combined command for two molecules, but the input file contains coordinate of four molecules, so I got confused. So what happens is that when you give the combined comments, it will generate different isomers, and you need to delete the isomers which you don't need. There's a checkbox where you can see which are the structures are considered. So if you remove that checkbox, then only the of the isomers what you need will be there for your optimization. The other questions what I often get in the forum also is that in the lectures where I have shown a hydrogen bond, or in lectures where I have shown a double bond, you may not be getting the same thing. And then the question happens that why I'm not getting the same. So remember, this single bond or double bond or triple bond, they are just representations. They are not observable. In quantum mechanics, you cannot really have an observable called bond order. So this bond orders helps us to understand how the strength of the bond. So chemists are very fond of working with the bond order. But your graphical user interface, the way it understands what is the bond order, it's actually calculated from distance. So it has a threshold. If it falls under this, that will be triple bond. If it goes to a slightly longer threshold, it will be double bond. And if it is more than that, it will be single bond. So now what happens is that often during optimization, it maybe slightly deviates from that threshold. And in that case, you will not see actually bond when you are going to open it with the GUI. But remember, the bonds are not observable. So if your bond length are coming fine, does not matter it's showing double bond, triple bond, or hydrogen bonding. It does not really matter. Okay, if you have any further question, feel free to ask so that I can answer. I don't see any questions. Maybe if there is any question unanswered from the forum, the TS may ask it to me so that I can answer.
Sir, your audio is mute.
Yeah, I don't see any questions. Maybe we have given a very short notice. I don't know. I don't see any more question. Uh, I think there is nothing in the forum also. So shall we close it down?
Sir, it's up to you. If you want to close, we can close.
I think we can close because I don't see any questions.
Should we wait?
Okay, let's.
Uh,
You want to wait for some time?
maybe 2-3 minutes more.
Okay, after 2-3 minutes we can close.
Okay.
Yes, Maya asked some question. Maya, please go ahead and ask. Maya, please go ahead and ask what exactly is your question. And I would be also interested to know why you want to join the two structure. Is there any specific reason? Maybe there are better alternative than Chimera X. Okay, my question is how you want to optimize the two structure together. Is there a specific purpose? Good afternoon, Shruti. Maya, so the thing is that if I need to optimize the two structures together, I believe you are trying to understand what's the bonding pattern between the two molecule. Correct me if I'm wrong. I think the easiest way is to use the Orca Docker, so make the structure separately. Use the Docker algorithm to find out the best possible orientation, and then actually do an optimization together. I would use XTD. Uh, not any other method for optimization also. Or if you think that extreme, if it's a molecule is bigger, you are dealing with large biomolecule, I would go to either or this so-called GFN force fields, which is inbuilt into the Orca, and you can do it much more easily than trying to do it with Chimidax. Because the advantage of using a standard software file for doing this kind of optimization is that okay. So now this is him. So for this one, I will just use the Orca Docker. Because the molecules you are given is not super big. XTB should be easily able to find out the best possible orientation. And the good thing is that it will not only give you the lowest possible orientation, you will also have an idea about the other possible structure, which is slightly higher in energy. Now, why they are important to know about the slightly higher structure, which you are not even maybe you may say that okay, they are high energy, so why I should get bothered? Remember, you are doing the actual experiment or whatever the thing is happening, it's actually happening in the room temperature. So that means there are some temperature available. So due to the Boltzmann distribution, what may happen that some of the high energy structure may be accessed. Of course, one need to find out the energy difference between the two, the lowest energy structure and the highest structure, to see that is it thermally accessible at not at room temperature. But generally, it's a good idea to know what other structures are possible, and maybe some interesting insights will be available with this. Chimera X is generally good if you are dealing with biological molecules like a full entire protein and other stuffs. For most of the other purposes, again, like what GUR you are going to use, it's like a personal choice. Everyone is comfortable with one with the other. These days, I find Chemcraft to be the best possible option. Okay, it cannot generate the input file as such, but it can do many other things. It can find out the spectra. It can show you the orbitals. The picture qualities are decent if they are not production quality always, but they are decent thing, and it helps you to understand very easily. And thing is that the Chemcraft you can go get a 6-month all trial license, which is not so bad. And even I believe there are some free version of Chemcraft which are available, which has limited features. Avogadro, on the other hand, the advantage is that it can generate you an input file. It can do many of the other file features, but problem is that it's not always up to date with the current version of Orca. So using Avogadro comes with the caveat that it's not compatible with the latest version 6 of Orca. And it's always advisable to use the latest version of the software, because many of the issues has been ironed out, many of the bug fixes are available, and generally there are some speed up when you use the recent version of the software. I hope that becomes clear. Any more questions? Please go ahead if you have any more question. No question is stupid. No question is trivial. Okay, one thing I did not describe at all in this course is to how to run Orca parallel. And the reason I did not do it because most of you will be primarily using it for the time being on a laptop, and I did not really wanted to. Okay, well, okay. Let me finish this, then I will come to Maya's question. Um, the reason is that the why I did not show the parallel one is because the parallel one sometimes takes more processors. So for a laptop, that will be too much. Now, the thing is, when we go to parallel one, of course, the speed up actually is much more, and it can finish your computation in much smaller time. But the thing is that Orca is not a massively parallel program. So if you think that Orca will scale over thousands of cores, it's not going to happen. So if you have access to a supercomputing facility, Orca generally does not scale over 2 nodes. Even 2 nodes, it will be stretched to its limit. So for most of the times, my default set of number of processors for parallel calculation will be either 8 or 12. Beyond that, Orca does not scale. Moreover, if you are doing so Orca, there's a distinct difference between Orca and Gaussian, how the memory is handled. So in Gaussian, if you give, let's say, 10 GB, and if you give 10 processors, then that 10 GB will be divided among 10 processors. So basically, each processor is going to get 1 GB, and your total memory count will be 10 GB. Whereas in Orca, if you give it 10 GB and give 10 processors, then each processor is going to use 10 GB. That means for 10 processors, you total have 100 GB of memory. And you need to see that if your machine actually has 100 GB. If it really goes beyond the capacity of the machines, if a machine has 96 GB and if you give 100 GB memory, allocate 100 GB memory, what will happen is that it will start swapping. So basically, there is a partition in Linux machines which is called swap, where the temporary things from the memory can be passed. Now, the moment it will start swapping, the process will become very slow. And like even if you are running 10 processors, it may be slower than running in one processor. So one need to be really careful while giving the number of processors for parallel runs, and really need to see how much memory is available. Generally, a rule of thumb is that you multiply the number of processors you are giving with the memory you are allocating, and that should not be more than 80% of the total memory available in that machine. So one need to keep a little bit of care while doing the parallel run. Okay, where you will find Orca Docker. So Orca Docker is an utility in Orca, and you can run it by doing the calculation. So if you go to week 7, lecture 38, which is termed as potential energy surface 3, and there we have shown the use of the Orca Docker, and the input file is available. You can try to do it yourself. If you face any problem while doing this calculation, feel free to post in the forum. Someone will reply to that. I hope that becomes clear for you. Okay, in forum, someone has asked that can we do optimization bands and DOS calculation with some samples like monolayer graphene and doped with various transition methods? The answer is yes and no. So Orca does not have any solid state code or plain web based code. So in principle, you cannot do any solid state calculation in using Orca. Although the way out of it is that you can treat a solid state like a QMMM method, where you embed. So basically, you treat the surface as an embedded clusters, and you use them, the ECPs, to make sure that they behave like a periodic solid. But to me, that's not a very good approach. If you want to see the details, the manual actually has a lot of details, and you can see the work of this Frank Nies's group from Max Planck Forschung, where they use this embedded cluster models to simulate spectroscopic of solids, and band gaps are also possible. But to me, if you want to really do solid state, you will I will go to a code which is dedicated for solid state calculation, which can use plane wave basis like VASP or CP2K. Uh, of course, Orca can do it like a QMMM, but generally it's not the best way to do this kind of calculation. Anyone else has a question? Another question: how large basis set is required to run piano-based calculation? Good question. Bigger the answer is bigger is the better. Def to TZ calculation, is it okay? If you ask me, a triple zeta basis set with an electron correlation method is never good enough. So one idea is to use a basis set extrapolation scheme. So you do a def to SVP and def to TZVP and then extrapolate it to the complete basis set limit. Or I will at least use the quadruple zeta kind of basis. That's the problem of the wave function based method. They are very accurate, but they converge very slowly with respect to the basis set size. So if you really need to get to the accuracy, which is like which is quantitatively correct, not qualitatively, I will at least use a quadruple zeta basis set or do a basis complete extrapolation to the complete basis set limit. For DFT method, although triple zeta basis set is generally always good. A DFT with except the double hybrid functions. So because double hybrid functional actually has an MP2 part. So except DFT, for everything else, triple like for double hybrid, except double hybrid functional, for everything else in DFT, the triple zeta basis set is generally good enough. Not for doing couple cluster or MP2 calculations. You at least need quadruple zeta or need to go to complete basis set limit. And Orca offers automatic approaches to go to this complete basis set limit. So you can explore that. Any more questions? Please go ahead and ask if you have any more questions. Okay, Maya's question is that can we solvate both hydrotropic and surfactant in OTA? Question is that what do you mean by solvate? Uh, do you mean implicit solvation? Do you mean explicit solvation? What kind of solvation you are looking for? So if you really want your life to be simpler, then I will just stick to the implicit solvation method, CPCM or Cosmo. And basically, to calculate the solvation free energy, we are going to use the Cosmo RS scheme. If you go to the lectures on solvation or environmental effect, you will see how to do this implicit solvation calculation and how to use Cosmo RS to calculate the solvation free energies. But remember, implicit solvation gives you only the polarization part of the solvation, and Cosmo actually also includes some environmental interactions and hydrogen bonding. So the rates what you will give will agree qualitatively, but quantitative agreement may not be possible with implicit solvation. To get quantitative agreement, you need to go to explicit solvation, but that comes with its own caveat. You need to do averaging, and one need to be really careful how you are treating the solvents, QM, MM, where is the boundary. So for all practical purposes, I will just stick to the implicit solvation and maybe use the Cosmo RS model to calculate the reaction free if you are interested in. Okay, explicit solvation use, if you want to use, the easier part is to start with the Orca solvator, so which will create the solvent distribution around your molecules, and then you can try. But I would suggest that if it does not really, you are interested into looking into some sophisticated solvation effect, uh, some sophisticated spectroscopy of which arises due to the interaction of the solvent and the solute molecule. I think for most of the purposes, the implicit solvation is a good bet to start with. Do Indian universities has internship in theoretical chemistry? Yes, many of the Indian universities, especially the IITs, offer generally 6-month internship, and that happens due to the through the IIT Bombay. In case of IIT Bombay, which I know much better, is IRCC internship, which is offers 6-month internship for students, and they get paid some honorarium for doing this internship. So you may want to check out the things, but most of the cases, these internships are restricted to Indian students. Foreign student, there are different other schemes available. So if you want to get internship somewhere, it's advisable to directly contact the person you want to work with. That's generally more advantageous. And but generally, IITs offer internship to students, to teachers who are employed in some college and universities. For them, there are also internship opportunities available. And for teachers, those who are employed in college and universities, they can generally spend the summer doing some research. For that, their formal program exists. Any more questions? If no more questions, then I believe I'll wait for 2 minutes and then I will close. Okay, as no more questions, so I'm going to close it here. If you have further question, please put it on the forum. Someone will reply to that. And thank you all for joining.
Thank you, sir.